Okay, so we're here. One change, 1.6. I'm going to throw out problem number 6. There's a problem with it. There's a mistake that they give us there. So skip problem 6 in 1.6. Okay, skip problem 6. And so we are here. Again, cross off anything that says 1.5, doing 1.6. Okay, so 1.6 today and tomorrow. And tomorrow I'll give you another quiz. It'll be just like last week's, only this time everybody's responsible for every problem. I'll break you up into your breakout groups, but everybody does all the problems, okay? All right, so that takes care of that. And now we are ready to start. Okay, so I was going to do problem 5 for you. So let's look at problem number 5. 1.6, page number 50. All right, so they give you a function here. And determine the values of f of -1, f of 0, f of 1, and f of 3. Okay, that means inside the parentheses, these are x values, right? So pretend that's x, that's x, that's x, and you're figuring out what the y coordinate is. That's all. So f of -1, I go to -1. The y coordinate looks like it's 0. So the answer to the first one is 0. F of -1 equals 0. Then it asks for f of 0. In other words, when x is 0, what's y? So that kind of looks like -1/2. So I'm going to go with -1/2. Okay, then it asks for f of 1. F of 1 looks like it's 0. So f of 1, the third one, should be 0. And then f of 3 is down here. So where's here? Looks like it's -2. So the answer to the last one is -2. Okay, then it asks for the domain and the range of the function. Domain is the extent of x. How far does x go? Range is how far y goes, up and down. Okay, so domain is for x, range is for y. Again, if you want to put that in your cheat sheet, you may. So for this function, how far left and right does it go? Well, the furthest left seems to be -2, including the -2. The furthest to the right seems to be 3, and including the 3. So for number 5, the domain should look like this. The domain, I'll abbreviate domain and range with D and R if the context is clear. So bracket, -2, 3, bracket. Okay, so this means everything between -2 and 3, counting -2 and counting 3. Okay, and the range, it looks like the same thing for the range. So the range is also bracket, -2, 3, bracket. So you want to copy that down if you wish. Range, bracket, -2, 3, bracket, but let's see why now. So for the range is how high and how low it goes. The lowest value is also -2, including the -2. And how high does it get? It gets up to 3 and including the 3. Okay, so that's why it's written like so. Okay. All right, again, we're skipping 6. And let's see, 7, 8, 9, and 10. We can knock them all off, they're very easy. Determine which of the curves are graphs of functions. So is it a function or is it not a function? Okay, and you might recall a function passes the vertical line test, right? So if I draw a vertical line anywhere, if it touches 2 points, not a function. If it doesn't touch 2 points, it is a function. Okay, so let's look at 7. Okay, number 7 here. I go like that. So is it or is it not a function? 7 is a function, right? If I draw a vertical line anywhere, it's only going to touch at 1 point. Okay, how about 8? Goes like this. Does that look like a function or not a function? 8 is not a function because I can draw a vertical line several places, right? If I draw vertical lines in several places, it looks like it'll touch at more than 1 point. So 8 is no, not a function. Okay, 9 goes like that and like that. So is 9 a function? It looks like the answer for 9 is yes. If I draw a vertical line anywhere, it's only going to touch at one point at the most. So 9 is a function. And then 10, they give me a circle. Is 10 a function? And of course the answer is no. I can draw a vertical line in several places, but touch at 2 points. Okay, so 10's a no. And that's it. And yeah, as I said before, on everything you turn in, homework, quizzes, tests, show all your work. But these problems, there is no work. It's either yes, it is, or no, it isn't. There's no work that you have to show. So that's it for that. Okay, we have 11 through 14 all, A-L-L, so I should do the evens for you. So I wasn't going to do all of them. Okay, so for 12, give the domain and range of the function. Okay, so let's look at 12. So the graph of 12, and by the way, they're already telling you these are functions, right? So do you agree? 11, 12, 13, and 14, they are functions. They all pass the vertical line test, right? But that's an aside. Okay, so 12 goes like this, then it goes like this, and then it goes like this. So it looks like we do not have -4 in the domain. We do not have 4 in the domain either, but it looks like we have everything else. And even though they don't show it, pretend this keeps going. Like I would put an arrow, okay? It keeps going there and going there and going there and going there and so on. So it looks like it's all real numbers except for -4 and +4. There's a couple ways you can write that. So let me see if I can try to show you at the same time. I'm trying to show you the graph and the answer at the same time. Yeah, sort of. Okay, so I'm going from -infinity to -4, union -4 to 4, and these are all parentheses because we're not counting -4 or +4, union 4 to infinity. Okay, so this branch here is -infinity to -4, then this one -4 to 4, not inclusive, not counting either -4 or 4, and then from 4 to infinity. And recall -infinity always has parentheses, and +infinity always has parentheses, and -infinity is always on the left, and +infinity is always on the right. Okay, this is correct, although I think this is a little bit nicer. The set of all real numbers, so that funny looking R is all real numbers minus the set consisting of -4 and 4. So all real numbers, throw out -4, throw out +4. That's also, to me, that's a lot easier. Okay, never mind about that, I messed up. Okay, the range is how high and how low does it go. Okay, so for number 12, it seems to drop down to -infinity. Okay, so -infinity, and then it goes up to 0, and it includes 0. So if I'm counting 0, parenthesis, -infinity, 0, bracket, meaning I'm counting 0. Okay, so -infinity to 0, then it misses stuff here, and then right up to here seems to be 2. The reason why I say that's 2 because they told me this is 4, right? So this is 4, this must be 2. And these aren't quite going to be touching 2. Okay, so I'm not counting a 2. So parentheses, 2 to infinity. Okay, so 2 to infinity. Okay, and again, we have some asymptotes. Okay, so asymptotes are lines the graph approaches. Okay, so we have, let me just write down asymptotes. So in that graph, it looks like we had x equals ±4 and y equals 2. We'll do a lot more with asymptotes later. Okay, so x equals -4, x equals +4. Those are asymptotes. The curve gets really, really, really close to it. And y equals 2 is also an asymptote. So x equals ±4, y equals 2 are asymptotes. It doesn't ask for that in the problem, but I just give it to you extra anyway. Okay. All right, then 14, and I wasn't going to do 11 or 13. They're odds. You have the answers in the back of the book. Okay, so it just goes like this. So domain and range. So it goes all the way to -infinity. Pretend it goes all the way out. And it stops at 2, and does it include 2 from this picture? No, it does not. Okay, so when I put the 2, it's going to be in parentheses. So for 14, the domain is parenthesis negative infinity, comma 2 parenthesis. Okay, so the parenthesis means I don't actually count the 2. So not quite 2, but 1.9999999 is there. Okay, the range, how high and how low. So it goes really, 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 really close to 0, but not quite 0. This is meant to be another asymptote. Okay, the word asymptote, A-S-Y-M-P-T-O-T-E. Okay, it gets really, really, really close to the x-axis, but doesn't quite touch it. So parenthesis 0, and this thing shoots up to infinity. So the range is paren 0, comma infinity paren. Okay. So that's it for that one. All right. Okay, next one I wanted to show you was, jump to which problem here? Sorry, just bear with me a second. Okay, let me jump and show you. I'm going to go a little bit out of order here for a reason. 23. They give you a function and they say, determine the numbers in the domain for which f of a equals b for the given value of b. All that means is set the function equal to 0. For 25, you would have set it equal to 1/2. So I just solved x squared minus 1 equals 0. That's what it means. The wording's kind of funny, okay, but it means just set x squared minus 1 equal to 0, like that. Okay, so when they say b equals 0, y equals 0, so just solve that. 0 equals x squared minus 1. That's all. So add 1 to both sides. If I add 1 to both sides, you have 1 equals x squared. 1 equals x squared. Take the square root. Okay, don't forget the plus and minus. So x equals plus or minus 1. Okay. Or specifically in the problem, they said call it a. I know it's kind of weird to switch it, but it's the same thing. So x is plus or minus 1, or a equals plus or minus 1. Frankly, if you left it as x equals plus or minus 1, I'd accept it. That's perfectly fine, as far as I'm concerned. Okay. All right, I'm going to jump over to 33 on the next page. I'm trying to give you a wide variety of problems. Yes, I'm kind of skipping around here, but there's a reason for it. Okay. 33 asks you for all this stuff, so I wanted to make sure that you had a chance to look at that. They give you x squared plus 2, and you want you to figure out all this stuff. F of negative x, negative f of x, f of 1 over x, 1 over f of x, f of square root of x, square root of f of x. So that's a lot of stuff. Don't worry, if you can't see all this, I'll show the whole thing to you. But you know, I wanted to at least show you that one. Okay, so 33. So about showing that to you. So here's the problem. F of x equals x squared plus 2. And if I went too fast, you know, and you couldn't see the book, that's okay. I wrote everything here. Okay, f of negative x. That means right here in parentheses, erase the x, put negative x. So I have negative x squared plus 2. But negative x squared plus 2 is the same thing as x squared plus 2. Okay, negative f of x just means this is f of x, right? So just give me the opposite of the original, but you do have to put it in parentheses. So it's negative parentheses x squared plus 2. Okay, so in other words, don't just put the minus in front of here because it isn't negating the whole thing. It's the negative of the whole thing. And now the negative distributes, right? So negative, negative. So the final answer is negative x squared minus 2, like that. Okay, the next thing they ask for is f of 1 over x. Okay, so we want f of 1 over x. Same thing right here. Pretend you erase that. Put parentheses 1 over x. That's the way a function works. Okay, so 1 over x squared plus 2. And then I square it. So what's 1 over x times 1 over x? Well, 1 times 1 is 1. X times x is x squared. So final answer, 1 over x squared plus 2. And you could just leave it like that. Okay, the next one the book asks for is 1 over f of x, which basically means just give me the reciprocal of this. So it's just 1 divided by all that. So 1 over x squared plus 2. That's the answer. So 1 over x squared plus 2. And there we go. Okay, the next one they asked for is f of radical x. F of square root of x. That means right here, whoops, sorry. Right here, right at the beginning, pretend you erase that x, put in parentheses, square root of x. Okay, so one more time, right here, erase the x, put radical x. So it's radical x squared plus 2. But what is the square root of x squared? Whenever you have the square root of x and you square it, you just have x again. So the final answer is x plus 2. And finally, the last one they asked for is the square root of f of x. It means just take the square root of the whole thing. So whatever they give me, put a square root about the whole thing. So there it is, square root of x squared plus 2. Right? So here's that. They want the square root of the original. So there it is, square root of x squared plus 2. And there we go. So I wanted to make sure I show you at least that one. And there's another problem that's like that, so use this as a template. Okay, so that's 33. I know on my paper I got 37, but I'm going back now. So sorry for going out of order, but there was a reason to it. I want to make sure I cover certain problems. Okay, so I'm jumping back now. Okay, so I've got that out of the way. I'm jumping back to problem 19. Okay. So yes, I know I'm going out of order, but I wanted to make sure, you know, I cover certain problems. So problem 19. Okay. So again, domain and range. X squared minus 2x plus 1. Give the domain and the range. Okay. So I'm going out of order. And a quick reminder, when you submit your homework for me on the test, which is what, a week from tomorrow for the test, you don't have to put it all back in order. So you know how I jump around? I do problem 1 and 7 and 13. And today I'm jumping all over. And you say, do I have to go back and rearrange them? No, you don't. Okay, just submit the ones that I already did. Just take a picture of all that. And then if you go back and do the ones that I didn't do and just submit it, that's perfectly fine. Now, if it helps you to reorder, go ahead, you know, go back and put it, you know, 1, 3, 5, 7, 9. But you don't have to, as long as you know, got it. That's all I care about. Okay, so 19 says this, x squared minus 2x plus 1. It turns out this factors into x minus 1 squared. X minus 1 squared. That's a parabola, which opens up. Okay, it's your basic x squared moved 1 unit to the right, right? And by the way, what do you get when you plug in 1? You get 0. 0 squared is 0. So it looks like this. Okay, so for this particular one, it's nice to know a little bit of what the graph looks like. Okay, so domain and range. The domain is all real numbers. You can go as far to the left as you want. You can go as far to the right as you want. Or another way to think about it is in this expression, are you allowed to plug in any real number? And the answer is yes, right? There's no number that will give me trouble here. I can put positives, negatives, fractions, decimals, big, small, square roots, pi, e. Those are all allowed. So the domain is all real numbers. To me, the easiest way to write all real numbers is funny looking all, R. You could also say negative infinity to infinity, right? Because on a number line, you're going all the way to the left and all the way to the right. So if you ever see negative infinity to infinity like that, that's the same thing. That's still all real numbers. Yeah. I guess you could also literally write out all real numbers like ALLREALNUMBERS, but this is a little bit easier in my opinion. Okay, what's the range? Range is the extent of y. So how high and how low? Well, the lowest y value seems to be 0, right? Including 0. 0 is there, and then it just goes as high as you want. So bracket 0, comma, infinity, right? So that means I'm counting 0, and I go out to infinity. Okay, next one I want to show you was 21. It's a piecewise defined function. It's split into two pieces, right? So f of x is 1 if x is greater than or equal to 0, negative 1 if x is less than 0. Okay, now, before I go on, remember that f of x is like y, right? So it's like saying y equals 1, y equals negative 1. So do you recall what's the graph of y equals 1 or y equals negative 1? Those are horizontal lines, right? If all you see is y equals a number, it's a horizontal line. And do you remember what happens if it's just x equals a number? X equals a number is a vertical line. Okay. So I'll tell you what, I'll rehash that as a little reminder. So I'll carve out a little space here. If you see x equals a constant k, that is a vertical line. Okay, x equals a constant, x equals 2, x equals 5, x equals -8, vertical line. Y equals a constant is a horizontal line. Horizontal line. So if you just see y equals 1, y equals pi, y equals a million, y equals -1,000,000, horizontal line. Okay. So y equals 1, remember f of x is like y, right? Y equals 1, horizontal. Y equals -1, also horizontal. But this one is only for x is greater than or equal to 0. So there we go. So if I were to graph the entire line, I would graph this whole thing, 1 unit up. But it only says x is greater than or equal to 0, which means count the 0 and shade stuff that's bigger than 0. Now, for x less than 0, I'm over here. Okay, y equals -1 is this entire line. I would graph the whole thing. But since it's only for x less than 0 and not counting 0, I have an open circle at 0, -1, and then a shade all the way to the left. So this is what this funny graph looks like. Okay. By the way, notice it is a function. It still passes the vertical line test, right? Even right here, if I draw a vertical line right on the y-axis, it's only going to touch at one point because this point is counted, but this one is not. Okay, so the domain is all real numbers. You can put any numbers you want, or it goes as far to the left and to the right as you want. The range consists of only two numbers. Okay, what can y turn out to be? It's only going to be either -1 or +1. So for the range, you have to write it like this. Don't write it with parentheses. Don't write it with brackets. Because if you use parentheses or brackets, that means you're counting everything in between -1 and 1 also. But we don't want to include anything in between. We're only counting two numbers, -1 and 1. So you use these braces. So braces are to indicate a set of numbers. So you use braces for a set. Okay. All right, so now we have some more domain problems, only domain. So it looks like 27. And yeah, unfortunately, 27 has A, B, C, D, and a lot of the others have A, B, C, D, but Some of them are similar. Okay, so it only asks for the domain. For some of these, the range is very difficult, but we're only asking for the domain. Okay, so there's A, B, C, D. Again, I'll try to do enough so you kind of get the hang of it. Okay, 27C, f of x equals square root of 2 minus x, 27C. Okay, so we know, cover this up for a moment, when you have the square root of anything, it has to be greater than or equal to 0. So whatever is behind my pen, 2 minus x, I just set it to be greater than or equal to 0, right? You can't take the square root of a negative, that's not allowed. So I set this greater than or equal to 0. Okay, add x to both sides, and if 2 is greater than or equal to x, or traditionally we would write x is less than or equal to 2. This says the same thing as this, but we're used to having the variable on the left side, so I'm going to write it that way. So less than or equal to 2, that's 2 and negative 1 and 0, negative 2, negative 80. So the domain is parenthesis, negative infinity, bracket 2. Negative infinity, comma 2, bracket. Okay, now D, I got the answer right away. It almost looks the same, but let me show you what's happening for D. So 27D, whoops. Okay, so I just did C. What's the difference between C and D? Radical 2 minus x. This one also has radical 2 minus x, but it's on the bottom. So the difference is here, you're not allowed to have 0 on the bottom. This expression is allowed to be 0. What number would make this thing 0? 2, right? 2 is okay here, but 2 is not okay here because it's on the bottom. So the answer to D is going to be the same as the answer to C, except I throw out the number 2. All the other analysis is exactly the same. Okay, so that's why I can quickly say for 27D, it's the same answer as C, except instead of bracket 2, it's parenthesis 2. Okay, so the domain for letter D is negative infinity, comma 2, paren. It was the exact same function. It was the exact same function, except it was in the denominator. Since it's in the denominator, we're not allowed to have 2. 2 is okay here, but 2 is not okay when it was in the denominator. So domain, that's a D, sorry, we can't see it, is negative infinity to 2. Okay. All right, next one I'm going to show you was 31B. Jumping down to 31B, radical x parentheses 2 minus x. This actually kind of piggybacks on problems we did before. Okay, so 31B. Where'd it go? Here we are. Okay, so cover this up. If you don't like to look at it, don't look at it. So I say to myself, whatever's behind my pen has to be greater than or equal to 0, right? It's a square root. I can take the square root of a positive. I can take the square root of 0, but I'm not allowed to take the square root of a negative. So the thing behind my pen, x parentheses 2 minus x, is greater than or equal to 0. Okay, we've played that game before. Okay, so what number makes this 0 and what number makes this 0? I plunk it down on a number line. So what number makes this 0? Well, 0. What number makes this expression 2 minus x equal to 0? That would be 2. Okay, so right now on the number line, I plunk down a 0 and a 2. Since I have this line underneath, they're both closed circles. Okay. More exactly, if I plug in 0, it works. If I plug in 2, it works because I have the line underneath it. Now, if I did not have the line underneath it, they would both be open. And again, just for practice, if I plug in 0 here and here, I would have 0 times whatever is 0. And then this statement would say 0 is greater than or equal to 0. That's true. Likewise, if I plug in 2, put a 2 here and a 2 here, well, 2 minus 2 is 0. So 0 times anything is 0. Again, it says 0 is greater than or equal to 0. So closed circles. Okay. But if this line weren't there, if it looked just like that, just greater than, both of these would be open. Okay, and then once again, 3 regions. Okay, we don't know that this is shaded yet, but region 1, 2, and 3. So pick a number here, -1. Pick a number in the middle, 1. Pick a number here, 3. Plug in and just check the signs. Okay, we don't need the exact value. So put -1. -1 is negative. Put -1 here. 2 minus a -1. 2 minus a -1 is a positive. So that's going to give me a negative times a positive, which is negative. Is a negative greater than or equal to 0? No, that's false. So I do not shade in region 1. Okay, region 2, plug in 1. 1, positive. 2 minus 1, positive. Positive times a positive is positive. Is a positive greater than or equal to 0? Yes, that's true. So I shade in region 2. And finally, region 3. I plug in 3. 3 is positive. 2 minus 3 is negative. So I have a positive times a negative. That comes out to be negative. Is a negative greater than or equal to 0? No, it's not. That's false. So I do not shade in region 3. So the only region is 2. So my domain is bracket 0, 2, including 0, including 2. And that's that one. So those are the only numbers I'm allowed to plug in. So the problem's finished, but just digging a little deeper. I can plug in 0, I can plug in 2, anything in between, but I'm not allowed to plug in, say, 3, okay, or 4, or 5, or 80, or 1,000,000, or -1, or -3. Those are not allowed. Only stuff between 0 and 2, including 0 and including 2. Okay, so I got that out of the way now, and I think that's as much as I have for there. Okay, so now I'm going to jump forward again, and let me see if I can show you on the next page, 37. Again, I'm just trying to pick problems off of here, a representative sample of all the problems that are here. Okay, so 37 asks you all this stuff here. F of x plus h, f of x plus h minus f of x plus h minus f of x all over h. And then it says the value of c as h, that arrow there, that arrow means approaches. Okay, h approaches 0. This concept you'll see a lot when you get to calculus. Okay, so they're trying to set you up for it since we're in pre-calculus. This word expression, f of x plus h minus f of x all over h, you're going to see that a lot when you take calculus. Now, don't worry about it too much now, but we're just setting you up for that. Okay, and what does this approaches, h approaches 0 mean? It basically means after you get your expression, plug in 0 for h. Okay, but I'll show you how to do that. Okay, so if I have time, let me try to show you 37 and maybe 43, but I'll show you at least 37. Okay, I'm going to go straight to C. I'm not going to do A and B because if you stop and look at it, if I do C, I've already done A and B, have I not? If you look at this weird expression for C, it includes part A, it includes part B. So to save time, I'm going to jump straight to C. Okay. So the expression is f of x equals 3x minus 2. Now they want you to figure out this weird thing, f of x plus h minus f of x all over h. Okay. Now, the easy part is the h. I mean, you got to at least have that. Just leave the h. Okay. And now at the top, This is certainly harder than this, but this f of x is just the original, is it not? So it's going to be minus parentheses that, right? It's supposed to be minus f of x. So it's minus parentheses the original. Okay. Now the hard part is f of x plus h. Okay, so the way functions work again is, let me cover it up. Whatever is behind my black pen there goes right here in parentheses, right there. Okay, so behind my black pen, if it said 7, I would go 3 times 7 minus 2. If it was E, 3E minus 2. If it's a mess, 3 times the mess minus 2. Well, I have a mess, x plus h. So that mess goes right there in parentheses, and there it is, 3 parentheses x plus h minus 2. So this expression right here, and I've got that in red, that's my f of x plus h. This stuff is f of x plus h minus the original f of x all over h. Okay, now it's just a little bit of algebra. So distribute, so 3x plus 3h minus 2, and distribute, so minus 3x minus a minus 2 becomes plus 2, right? So all of this junk here is 3x plus 3h minus 2 minus 3x minus a minus 2 plus 2. Everything cancels out except for the 3h. That cancels with that. Do you agree? 3x minus 3x. Negative 2 plus 2 cancels out. So I just have 3h over h, and 3h over h is 3. So the final answer is 3. Okay, part D really doesn't apply. Okay, I know it doesn't really make sense right now. It says h approaches 0. Okay, so I got it in words, h approaches 0. It doesn't apply here because this expression doesn't have an h. But if this thing had an h, let's say there was some h stuff here, you would now plug in 0. But in this case, it doesn't apply. Okay, so the answer to D is also 3. I think what I'll do, yeah, I think I have the time to show you one more where it does apply, and that would be 43. Okay, so it's almost like saying here, plug in H wherever you see it. So right here, wherever you see H, plug in 0. Well, I don't see it anywhere. So I've done it, right? I have plugged in 0 everywhere I saw H. I did do it because I didn't see H anywhere. So the answer is 3. Okay, but that would apply more for the next one I was going to show you, which is 43, and maybe that's all the time I have after that. So I think 43 will be my last one. So let's see. So 43, 1 over x. Yeah, so I'll do 43. Again, I'll jump straight to C and D. Look at the words. If I do C, I've done A and B, right? A asks for that, B asks for that. They're included in C. So I'll go straight to C, and then I'll do D. What happens as H approaches 0. Okay. So for 43, please, the function is 1 over x. So part C asks for f of x plus h minus f of x all over h. Okay, so the denominator is h. We got that down pat, right? Now the hard part, the top. Well, this should not be that bad. Minus f of x, that's just the original, 1 over x. So in that f of x plus h minus f of x, the thing on the right-hand side is just going to be 1 over x. Okay, see that right over here? And now f of x plus h. Okay, so pretend you erase that x. Okay, and now behind the blue pen, put parentheses x plus h. So it's 1 over parentheses x plus h, but I realize, hey, I don't really need the parentheses. So I have 1 over x plus h. So this is this. F of x plus h is 1 over that minus the original f of x all over h. Okay, so this thing here is sort of the answer, but you don't leave it like that. I mean, that looks too weird, right? You have a fraction on top of a fraction. So we have a main fraction bar, main fraction bar, top and bottom. But in the top, the numerator, there's a fraction there too. So we don't like the way that looks. Okay, so how do I clean it up? So here's how you clean it up. Okay, now remember h is like h over 1. So I'm dividing by h over 1. So if you divide by h over 1, you multiply by the reciprocal, 1 over h. Right? Again, if you divide by a fraction, h over 1, it's the same as multiplying by 1 over h. And then bracket out, and then I put the top. Okay, so temporarily ignore the red. That's what I have, right? 1 over x plus h minus 1 over x right there. Okay, so right now, all that I did was that h on the bottom right there, I made it into a multiplication by 1 over h. And now I have 1 over x plus h minus 1 over x. So I cannot subtract until I get a common denominator. So the left side has x plus h on the bottom. The right side has x. So you know what to do. The left side needs the right, and the right side needs the left. So this side needs x over x. This side needs x plus h over x plus h to get a common denominator. Right? Little timeout. It's just like, how do you do 1 over 7 minus 1 over 5, right? Well, this side needs 5 over 5, and this side needs 7 over 7, right? It's the same thing. So if you see this, then you would just go, oh yeah, 5, 5, 7, 7 in arithmetic. So same thing. This side needs x over x. This side needs x plus h over x plus h. Okay, so now I have this, 1 over h. Now they have a common denominator, x times x plus h. So there it is, x times x plus h. And now I work out the top stuff. So what's 1 times x? X. Negative 1. Now be careful. The negative 1 distributes. So it's negative 1 times both of them. So negative 1 times x, negative 1 times h. That means they're both going to be negative. So I have x minus h on top. And the x's cancel out. So that means now I just have negative h on top. Negative h on top. The bottom has h times x plus h. Okay. 1 times that is, leave it alone. So negative h over h, x plus h. H's cancel out. So I have negative 1 on top. So my final answer is this. Negative 1 over x times x plus h. And now this expression does have an h. So unlike the previous one, where you would then plug in 0 for h, but say, hey, I don't see an h. Okay, but that does apply here. So for part D, you'll see this symbol in calculus, h arrow 0, h approaches 0. Don't worry too much about it right now. It just means now plug in h equals 0. So put a 0 right there, negative 1 over x, parentheses, x plus 0. Well, x plus 0 is just x. So you just have x times x, and x times x is x squared. So final answer is negative 1 over x squared. And that's about it. All right, so that'll do it for today, folks. So I'm going to stop the share and turn off the recording. All right, and see, there's nothing in the chat. Okay, so what do we have? About 5 minutes left. So anybody have any quick question? And if not, then we can just call it a day from there. Right, so.
I have a quick question for 21.
Okay.
Just like, can you repeat how you found the range? Because I got a little confused.
Okay, 21. Yes. So 21. See if I can find it here. Oh, sorry. Okay, so go back and share one more time. Okay, so the range is a set of y values. Okay, so what y values are allowed in this function? The only y values are negative 1 and positive 1, and nothing else. There's nothing down here. There's nothing in the middle. There's nothing up here. So for this function, y can only be either negative 1 or 1. So the way we write it is like so, with braces. See, we're used to having intervals. like we're going from, -7 to 25 or whatever. Okay, but not here. We're not including any in between stuff. So you must not write it with brackets or parentheses. We use braces for a set. So only -1 and 1. And that's what we're trying to say there. Okay, that's all that's allowed.
Thank you.
You're welcome. Okay, anybody else with anything, please? Okay, I don't hear anything, so that'll call it a day then. So tomorrow I'll start lecture, then you'll have your second quiz. You already had one quiz last time, so you know what it's like. I'll stop after a while, break you into your groups, give you the quiz, but this time and for future quizzes, everybody's responsible for all the problems. Okay, I'll be grading you individually rather than by a group from here on out, okay? All right, I guess that'll do it for today, folks. So have a good day. We'll see you guys tomorrow, okay? All right, bye everybody. Good day.